Good morning, good afternoon, or good evening, depending on where you're tuning in from today. We want to thank you for joining this TechStrong learning experience with Harness. My name is Jared, and I'd like to welcome you to another one of our TechStrong learning programs. This session is going to be recorded and available on demand. We'll send you a link after the recording concludes. Just a few housekeeping notes. We do have some handouts in the resource section on the left side of your screen, and we're also going to be doing some polls today, so make sure you stick around. Answer those. We want to see what you have to say about the polls. Also, we've got the chat on the right side of your screen. We want you to share your experiences, share your comments, your understanding on the matter. Just let us know why you're tuning in today. We want to hear from you. We've also got the Q&A panel on the right side of your screen. Make sure all of your questions go into there, and we'll answer those at the end of the program. Any questions that we're not able to address in today's program, Matt will reach out to you after the program ends here. So let's go ahead and kick off today's topic. We've got software under pressure, mastering resilience testing. We're joined with Matt Schillerstrom, Director and Product Manager here at Harness. Matt, you want to go ahead and take it away from here? And once again, thank you for joining us. And I'm going to turn my camera and microphone off.
Yeah, thanks, Jared. Appreciate you. But yeah, hey, everybody. My name is Matt Schillerstrom, and I'm excited to talk to you about software under pressure and mastering resilience testing. Now, curious, anybody out there know what this image looks like? On my next screen here, I actually took Queen's Under Pressure album, their Hot Space, and kind of made that theme. I'm not going to sing any songs, but what I will say is, software under pressure, pushing down on systems, pushing down on code. So if anybody wants to sing that tune with me later, we can hop on a different Zoom call. But yeah, happy to be here. I've been at Harness for about almost 3 years now. I'm currently a director of product management. And I also am a community builder for Litmus Chaos, which is an open source chaos engineering tool. Previously, my experience and career after college, I worked at a nuclear power plant for 13 years doing all this cool stuff. Then I went to Target, worked on Target.com's resiliency. I was a disaster recovery tester turned chaos engineer. I went to Gremlin for a few years as a product manager, and then came over to Harness, where I'm at today. And just a little bit about Harness, where I work. We started out as a CD, continuous delivery company. But over the years, and since I've been here, we've added more and more modularized solutions that work independently or better together. And specifically what I touch, like my experience, I work with, chaos engineering, which I'm talking to you about today. But I also work on service level objectives, or service reliability management tool, feature flags, database DevOps, which is really cool because everybody touches app codes, but along with any app changes, we have database changes, and we can help out that. And then a new module for incident response as well. And then it wouldn't be, a webinar if I didn't talk about Gen AI, or I won't talk about MCP today if that's the latest buzz, but we are also building agents that span across all of our modules too, just to make it easier and to communicate across the solutions better as well. And today, during my demo, I'll also kind of show some of our agents that we're building with chaos engineering for AI recommendations and fixes. And just to let you know, I mentioned Litmus Chaos because I help out with that project, but just a little background on that as well. So we donated it to the Cloud Native Compute Foundation, the CNCF, a few years back, and it's an incubating project. We're hoping it can be a graduated project, similar to like Kubernetes. Kubernetes is a graduated CNCF project, but today, we have lots of use with Litmus Chaos, lots of stories. It's free, it's open source, and you can go download it today, self-host it, and get up and running with over 50 chaos tests out of the box. But as you can see, there's a lot of public adopters that use Litmus Chaos, and it's growing more and more. And if you ever attend a KubeCon event, whether you're in KubeCon last week in Europe or upcoming in North America, in Atlanta this, I believe, November, like we have a Litmus booth there where you can come and talk to us as well. All right. And before I kind of run through the agenda, I'm just going to have a poll open up, and I'll start the poll. And if you could click over on the poll tab, I'm just curious, who I'm talking to today, whether you're a site reliability engineer, DevOps, performance, QA engineer, or other. So just click on that, and that can maybe help me tune my presentation today, who we're talking with as well. So that's great. But yeah, the agenda today, basically what we'll be talking about, is why performance testing isn't enough today. What is resilience testing? And then a live demo will all show some load testing with some chaos engineering experiments, and then some AI recommendations as well. And then we'll leave off with some takeaways, next steps, Q&A, that sort of thing. Great. And I'm just looking at the poll, and it seems like it's kind of everybody: DevOps, performance, QA, other. So awesome. Great to see that as well. So I'm just going to close that poll for now so that works. And yeah, just awesome. Hello to my friends in Ohio, New Mexico, and Colorado. I was actually just in Breckenridge, Colorado skiing last week. So love Colorado. Where I'm at in Minnesota, it's pretty boring and flat. We have 10,000 lakes, which is cool, but we don't have any mountains, which I appreciate. All right, cool. So why are you really here though? And what I'll say is you want to be a chaos engineer, right? Just kidding aside, but this is actually, a ChatGPT AI generated image. It's kind of going viral on LinkedIn with other people posting, but I decided to create my own chaos engineer action figure. And it's actually of my coworker, Uma Makara, who's our head of chaos engineering at Harness, one of the founders and co-creators of Litmus Chaos as well. But this is a fun chaos engineer that I want to give to you all, digitally here. But basically it comes with accessories, like a hammer to break things, a scissors to clip network cables to cause, network outages, coffee to spill on a server, and our friend, the little chaos monkey in the bottom right-hand corner as well. So hope you get a kick out of that. But whether you're, a QA or performance engineer today, I want you to kind of take back today, like some chaos engineering that you can do in your current job. And I always kind of talk about it, like the habits that you have today, how can you stack another good habit on top of that? And that's where I'll talk today about, like load testing, performance testing, stacked with the chaos engineering resilience testing habit as well. So you can do both at the same time. All right. So why performance testing, isn't enough today, right? So how teams are doing performance testing today, like how we do it at Harness, as well as where I used to work at Target. We have various teams doing load testing with tools like JMeter, K6, or Gatling, or Locus, or LoadRunner, all the same. When I worked at Target, we had hoped that application teams could use like one or two tools, but it seemed like they had to use the whole gamut based upon what programming language or infrastructure they're running on, which is totally fine. But there's definitely some great tools out there for load testing, and they're simulating high traffic, high transaction volumes. When I worked at Target, we simulated, hundreds of thousands of orders per hour on Target.com, to see if our system was scaled up enough, right? And then they're looking at, monitoring response time, throughput, resource usage, basically what's that customer experience on my, application when my infrastructure is scaled up with, 10,000 users, like what's that response time? Is it a good experience or bad, right? They're performance testing, load testing, right? They're taking the new code that was written, put into a container, perhaps put onto a pod within Kubernetes. And then how is it performing? Is the new Java code still efficient and running? At the end of the day, is my user still able to click buttons on a website with a good response time and everything? But the challenges outside of that, right, are all of these that you see on the screen today. And it's more than just performance. Honestly, like if an outage happens at 2 o'clock in the morning or whenever, it's probably not a performance issue. It's probably something to do with resilience. And, the challenges that you see on the screen based on news articles in the past year are prevalent, whether it's, cost issues or network outages or security breaches. There's all these things we have to worry about, right, and protect against, let alone the performance of the new Java app that we just released. And kind of brings me to my next poll that I was going to start. I'll keep that running for a little while, but I started a poll. Just, I'm curious, what type of pressure is your software team facing right now? Whether it's incident fatigue or release rush, you have a product manager like me or something that's, pushing you to release software quickly, or you have anxiety from reliability issues, or all of the above. But just kind of curious on your stance there. But what I was going to get at, like technologies and standards change. And that's why I'm here today talking about, other additional testing that you can do and couple up with, right? And this is kind of meant to be just a funny image of what like a car seat or car restrainer used to be like. And this is years ago. I grew up in the 80s, so my car seat looked more like a bathtub that was in the back seat or front seat. But this car seat, car seats back in the day were meant more so, can my baby see out of the window, keep the happy, right? But what I meant to articulate here is, as technology shifts and standards change, we have to adopt new practices and principles. And this is where, chaos engineering comes into play as well. I searched the internet the past few days just around some like new stats and just kind of like facts of what people are thinking about. And LinkedIn had this survey, your team is struggling with high pressure software testing, and how can you keep them focused and efficient? And what I really like about how these people responded, not only is it just testing, but they actually, it's about like making sure your team, understands the issue, has time for retro to learn so they can fix it, do better, as well as just reflect on it, have empathy for the people that are, stressed, right? It's not just the software that's under pressure, it's the human. So I really like this aspect of, people just thinking about their team and coworkers as well. Some other things I found too. So this is a LinkedIn post of a friend actually. So he's a business continuity professional, and I used to actually be a business continuity planner when I worked at the nuclear power plant back in the day in Minnesota. And what I love about this post that he was talking about is, here's the truth, right? A plan is only as good as the last time it was tested under pressure, right? And QA and performance engineers do a great job at testing, right, and creating that pressure for the system. But what I also like to talk about is like coupling that with proactive chaos engineering testing. And we'll talk about that, but it's basically, like having 10,000, 100,000, 1 million people using your website, load testing, and then coupling that with degradation, like a network outage. So how does like Target.com handle 100,000 people trying to order a Funko Pop doll? And then we have like an availability zone outage. Like, does my system correct itself, or does my customer experience degrade? And that's what I love about this post too, just with business continuity planning, is like you have a plan and you test it, but test it under pressure. And when I worked at the nuclear power plant, once we had drills like every day. We had our operations staff had to practice their response every day and every week. But every month we had a bigger drill. And these drills weren't just like, playing and reading scripts and everything. It was actually like simulating the event, right, under pressure with time. Like once this event happened, we had 15 minutes to respond to the event, get into the room, call the city and state, notify them of like the nuclear disaster that we were kind of like simulating. But that pressure is really what trains you and builds that muscle memory as well. And some other things I saw recently just in the news as well, right? Performance testing, it's also about cost optimization, right? And I had another friend post about this on LinkedIn, Scott Moore, who just says, performance testing isn't just about like the efficiency and speed of that like transaction. It's also the cost optimization and performance, right? And that's where like a lot of product managers, when you as engineers are talking about, making systems more reliable, like you love it, and product managers should love it too. But oftentimes you have to just flip the coin and say like, here's how it impacts cost. And this was just a great article where they're talking about performance testing with just making sure the traffic was steering. And here's another one too that I just found. And I love this because it's all within the past week, basically, of just people talking about it. And this person was talking about, taking default settings in Kubernetes, right? And how that cost wasn't performant. And even if you like do performance and load testing on like an application on the software and tune it, like the infrastructure might not be, performed and tuned as well. So that's where you can couple like resilience testing with performance testing, right? So you get the whole better picture of everything. And let's see, lastly, kind of what I'll show, and this is another like performance engineering expert, Scott Moore, that I follow. I welcome you to follow him too. But he was just saying like all the code and technical debt that's being generated by AI, it's going to be a huge gap coming up just with performance and reliability. So for all the QA and performance engineers out there, you're going to have a job for a long time, right? It's going to be great to kind of see how more and more, code generation and creation is going to not be easy, but there's going to be more, but the reliability, resiliency, and testing and stuff is going to be more required, right? It's not going to just be like this functional test that we have to do. It's going to be a hard requirement making it work. I'm just going to go to the poll here as well. All right, cool. I'm going to click on open, and it seems like people answered, what type of pressure. So a couple for incident fatigue, more so for release rush, like I got to get this feature out. Some have anxiety for sure, and most all above. So I appreciate that as well. Cool. All right. And then just another like advertisement, I guess, for somebody I follow on LinkedIn too, with ByteByte. These are all the tests that you as a DevOps engineer and SRE, QA have to kind of go through, right? With smoke testing, functional testing, integration testing, stress testing, security testing, all the like, right? And even fuzz testing at the end. And I was actually going to ping the guy that wrote this too to ask if I could help him write, resilience testing at the bottom of this is just another thing, right? Because there's just so many things that we have to do these days, but how do we make it easy? And what I'd like to say, kind of end with this section of the presentation is my main purpose, for leading into resilience testing is because it helps me understand how something works, right? And this person I follow like on X or Twitter at the time, who talks about building churches actually, and stuff. He always talks about problems. If you don't know how it's working, like when it's working, like you'll never know how to fix it when it breaks, right? And not to say like you need to learn how a motor works so you can fix your car. That's kind of hard. I do appreciate people that know how to do that or even fix a lawnmower. But if you are owning and operating a software system, you need to know how it works, right? And that's where doing performance testing and load testing, especially like proactive chaos testing, will actually teach you how it's working. So the things that you implement in your code, you can actually validate that it's actually going to work, right? And what I'd like to say, like what is resilience testing? And I have like a word cloud here. Sometimes like when I'm giving like a real like physical presentation at a conference somewhere, I like to kind of have people throw out like, what do they call their testing? But these are all things around chaos engineering today, right? And sometimes I don't even like to say the word chaos engineering. Like when I worked at Target, our team, was first the IT disaster recovery team, and then we switched to the chaos engineering team, but then we switched into resiliency engineering and then resiliency engineering enablement. So a few name changes based upon like what teams we were working with. But the term, chaos engineering can be like an unfriendly term, but it's a very proactive way of looking at, how do you understand your system, right? And just for those of you on the phone, right, that aren't, practicing chaos engineering, here's a quick definition of it, right? It's a controlled experiment, right, to test your system's resilience under that failure condition, right? And it's not about randomly breaking things and just kind of seeing what happens. It's about, forming a hypothesis, right? So I have this little chart here, right, where you're, figuring out what are you going to target, what are you going to test, how do you think it's going to respond, how am I going to observe the results, right, and how am I going to improve, right, and automate it. And this is just this hypothesis. You can kind of think of it like a scientific method, something that you like learned when you were in first grade about, having controls and variables and measurement. But it's very, people that do load testing and performance testing are very used to what chaos engineering is, because you're coming up with test suites, running it, observing it, and making it repeatable. And the need for this, right? Like modern applications are more and more complex these days. So the same, the Java applications that you're writing are now getting deployed onto complex cloud architectures. And a lot of times you see this, right, with monolithic apps, right? So people are writing a monolithic Java app that they're porting over to microservices. But now like things are decoupled, right? And it's supposed to be more resilient and self-healing, but it just gets more complex the harder it is, right? Especially like as you get things on containers and try to orchestrate thousands, if not hundreds of thousands of containers across like a globally distributed network. It gets super complicated. And especially when you see in the news like outages, right? Like these are just like some big outages over the past 5 years. But you can see like cloud outages or telecommunication outages or content delivery network outages. Like the big marker platform I'm using today for this webinar, like when I first joined the webinar, it was finding me the CDN that was most performant for this so that hopefully you have a good experience and my internet doesn't, get severed kind of a thing. But there's all these things we rely on today. But at the end of the day, if there's these outages, like how is your application going to respond to that failure? And it's even if your infrastructure can handle, 10,000, 100,000 users per hour, that's great, right? You need to start there, but like, how's it going to handle during that disruptive event? And that's where I see a lot of similarities, right, with performance teams and chaos engineering, right? These are all different use cases and outcomes that people can achieve with chaos engineering and performance testing. So like workload spike simulation, stress testing with resources, introducing latency between an API or a database to kind of slow down that network connection. Because oftentimes like a network outage starts with something smaller and grows into something bigger. Even looking at like the data layer disruption, like simulating like how my application handles a slow response to the database or even the cache. Because so many people implement a caching layer before their database. So maybe like a Redis cache layer for speed and performance, and then it eventually talks to a Postgres database. But you can do performance testing on all that to make sure it handles the reads and writes. But how do you make sure it handles the reads and writes during disruptions and outages, right? And then also scalability and auto scaling validation. A lot of these, chaos experiment suites that I'm showing you resonate very well with load testing and performance testing, and it makes sense. And the outcomes that I see with performance teams using chaos engineering are some of these, right? Like they're optimizing performance metrics, they're looking at their test suites, right? Because QA engineers always have their repeatable test suites that they're running. Like the developer hands off to a QA engineer, and the QA engineer has come up with these test suites that have to pass, that they have to measure, right? But you can get these baselines with chaos engineering tests as well to create that benchmarking framework. Then you can also just look at dynamic resource configurations as well. So performance, engineers are always looking at, my Java app is running on this. So what does my configuration and tuning need to be on this like container or pod or, higher level Kubernetes system? And that's where proactive chaos engineering can help you tune that and test it, right? So how does my application handle this failure during this network outage, for example? But what I'm seeing, in the industry today, right, is like performance doesn't necessarily equal resilience. And like I said earlier in the presentation, like if there's a 2 a.m. outage, it's often not like a performance issue. It ends up being like a resilience issue. And like the Uptime Institute recently, had a stat, not recently, but they always kind of say like, 80% or so of outages are due to like configuration errors and not capacity, right? And oftentimes like those load performance testers, like they do a great job and they catch like some sort of Java issue that just happened, right? They catch that before it hits production. But then they wait for an incident to happen in the future that reveals this underlying issue with the configuration problem. And that's where like, right, chaos engineering coupled with load testing and performance testing helps out so much. Cool. I'm just checking the Q&A chat as well. Cool. Yeah, love the question. I'll answer that towards the end as well. But yeah, please load up the questions. I definitely have time for that as well. And I'm going to start the last poll, just 3 today. But the poll, if you could, have you ever found an incident where performance testing was totally missed? So like yes, no, or just a funny post there. But what to talk about resilience testing a little bit more, I just was going to kind of go into more of my story working in the past. And back in about 2017, when I was working at Target and working on, old school IT disaster recovery plans, which I love, as I loved working with engineers, formulating their plan, testing it, documenting it, making them feel confident. So I was always trying to create a good experience. But I remember I was working with a gentleman who just shifted and landed his application onto Kubernetes. And he just told me, hey, I don't need to do a DR plan anymore, Matt. It's on Kubernetes. Kubernetes is self-healing. And this was like 2016, 2017, just after Kubernetes came out. And I had no idea what Kubernetes was. I was literally like Googling it on my laptop what Kubernetes was, because as you remember, I had just come from a nuclear power plant and they definitely weren't using Kubernetes. So I was researching Kubernetes and self-healing. Wow, I'm going to be like out of a job. I don't need to do DR testing anymore. And the gentleman told me to go talk to our platform engineering team at the time. So I went to the platform engineering team to learn about Kubernetes, to see how it worked, maybe to see if they needed a DR plan. And thankfully they were like, yeah, we need a DR plan for our infrastructure for sure. So I still had a job. So that was good. But they also told me like, no, that app team, like they need a DR plan too, because they need to know how to do backup and recovery and test. Like the app that they're writing, they can still write code that's not going to handle like a container or a pod restarting, right? Or like maybe they didn't size the Kubernetes resources for memory and CPU correctly, right? So it came this back and forth of everything with like learning about Kubernetes, understanding that it wasn't. I love Richard. Richard in the audience is saying we still hear that argument today. Absolutely, right? Like this was like 2016, 2017, where people were just saying like, hey, I don't need that, and pointing fingers. But I was able to kind of pull everybody together such that, we created like a DR plan for that platform, right? So that they met their SLAs and SLOs. We got to kind of bake that into the DR plan as far as metrics. And then working with the application team, we were trying to figure out, okay, well, what are these new problems, right? So they were like, well, we're already doing like load testing, performance testing, right? Because they were Java developers, they were used to that. They had a QA team that they were working with. But now some of the new failure modes, like on Kubernetes, just in the constraints, like how do we test that? And that's where we found, tools like Chaos Monkey, because we were using Spinnaker. So Spinnaker had built-in Chaos Monkey because that came from Netflix. But we also found some open source tools like Toxi Proxy, Chaos Monkey for Spring Boot for the developer teams are using that. So we ended up, shifting our disaster recovery team into more of that proactive chaos engineering team. And then we were doing, at first we were doing like monthly game days, giant pizza parties, if you will, teaching people like how to test their system proactively, right? But then also incorporating that into like a real disaster recovery test. So we only had to technically do a disaster recovery test once a year, which was great. And everybody, was fine with that. But we were trying to enable the teams to do disaster recovery testing more frequently. Maybe not on the whole system, but on, on what they own, the microservices. Because since, we had adopted best practices in CI/CD and enabling our developers to not only do like daily deployments, but within multiple times a day, right? So the change was constant, right? So then we were trying to convince everybody like that we needed to do this DR resilience testing more often. So that's kind of where we started to go. We had the monthly pizza parties, like where we were doing the game days and everything, which was great because it was making our systems more resilient, and most importantly, like our people more resilient and better like team players because we were learning through failure. But then it just wasn't scaling out that well, right? So we actually paired up with our friends over in the load testing performance engineering team. And they did their load testing more frequently. So then we enabled them self-service to do chaos testing with it. So kind of what I was alluding to before, as they were simulating, say 100,000 users ordering stuff on the website, they injected network failure, right? So they would slow down the network with latency to see how the API would degrade and see how their system would recover. And they would also like just sever the network. So just to see like, okay, did I get paged? Did my system self-heal? Do I have run books that are documented or scripts to call out? So we were able to kind of find the best in breed way of getting this resilience testing done by working with the load testing team and performance engineering team. And eventually, and again, this was like back in 2017, 2018, 2019, we found that sweet spot where they just were like, yes, this makes sense, right? I'm going to do load testing to make sure my system is performant, that my infrastructure can scale, but then I'm going to also incorporate resiliency testing with chaos experiments, just so I can understand how my system will react and respond in that failure mode. So it was this beautiful thing that was built out and enabled. And yeah, that's, I'm telling you this story to try to convince you that you should do this, right? And that it makes sense. And then it's easy, right? Now, the experience that I was talking about before, maybe didn't sound easy. It was 4 or 5 years of my career at the time building this out with a bunch of great coworkers. But today it's easier with a lot of open source tool and commercial tools as well. I'm just going to go back to my poll quick as well. So people, yeah, they found incidents, no, but now they're suspicious. And just a couple people that maybe say they debug stuff and cry. So it's great. I'll close that poll as well. And just a reminder, feel free to ask questions, because as I move into the demo, I'll have time for Q&A at the end as well. So the next part of this presentation, I'm going to go into a live demo and talk about like load testing and resilience testing and some AI recommendations and all that. But a couple more slides I was going to share before I go, just to kind of get you thinking. If you've ever heard of Chaos Monkey, Netflix built that out, 14, 15 years ago now. I'm dating myself for using it. But, chaos engineering today is a lot more than just, shutting off servers randomly. I like to say it's supercharged. And where I work at Harness, like we offer now, 223 out of the box tests that you can run on Kubernetes, Linux, Windows, any platform they're running on as well. If you say mainframe, I'll tell you we can look at a proxy setting up so you can interrupt the networking traffic between a mainframe and a dependency. But the tools, are best in breed today, whether you're looking at any commercial product or open source. We're now seeing service discovery in these tools, dependency discovery, security and governance for guardrails of, running your experiments, just to make sure, I don't want Joe to run this chaos test on Fridays between 8 p.m. and 10 p.m. And you can put all those controls and constraints in there just so you can make, chaos engineering self-service for teams and users, but also give them guardrails so they, it's harder to do that wrong thing, right? So yeah, and some other use cases I like to talk about too. So at KubeCon in Salt Lake City this past November, Global Payments was talking about implementing this awesome globally distributed database. Right there, they're installing, right, and putting out the system so they can handle high transactions. But what I loved about the story they were talking about is how do they protect this investment? So, I don't know the cost of this system they installed, right? But it was this beautiful presentation that's on YouTube, so you can go check it out. But they actually use chaos engineering to validate, the resilience mechanisms that they, installed with this database, right? So they ran a gauntlet of chaos tests to test the resiliency of that database, through network failure, through resource exhaustion, through database issues. So it was a great way to do that, like point in time snapshot of like, we're good. What we said we were going to do, we implemented and we tested and validated. And now you can like repeat the testing as well. And a couple more use cases before I click over into the demo as well. This is a really interesting one too. So you can actually, test Kubernetes resilience. So if you have, liveness or readiness probes that you're using Kubernetes as your, pod restarts, these are probes that you have to configure. You can actually use chaos engineering techniques to tune that, right? So sometimes people size the configuration too large or too small. So you can actually kind of see what that tuning should be. And this is one scenario we did at Target as well. So we had configured, when it should talk to the caching, when an application should talk to the caching layer or database, and everything like that. So we actually use networking experiments to check how we should tune that, whether it should be like 5 seconds or 10 seconds or 20 seconds of these probes configured before, things would stop hitting the caching layer and go to like the Postgres database, for example. And then one last use case before the demo too is this as well. So what's great about harness chaos engineering is that it's not just about injecting failures into your system. We have a whole pipeline where you can orchestrate your tests. So we can actually take like a service mesh like Istio, which has built-in chaos faults. Because as you'll see, as you use more and more technology, some chaos faults are becoming a commodity within like that product. So Istio has some mechanisms in place where you can have delays in your network. But we can actually like wrap that test in our pipeline so that you can create a pipeline that says, create a JIRA ticket, get approval, run this Istio test, and then let's score it too with a resilience score so that you're not just running the fault, once a week and forgetting what the results. You're actually like correlating it to a score so you can test it. And this is very aligned with like how load and performance testers and QA engineers work, right? They create that benchmark and baseline so that they can measure it again and again and make it repeatable. So those are just a couple of use cases. And then I'm going to click into a few things as well. All right, so just double checking. All right, so into my demo here, got a couple tabs I'm going to walk through just with in regards to chaos engineering and load testing. And this is kind of just how easy it is today. So I don't know what your favorite load testing tool is. For today, I'm just going to choose Gatling. But all I've done here is create a pipeline, workflow, if you will, where I'm going to kick off a Gatling load test. So it's going to actually prepare. Each load testing tool kind of works differently. The way that this workflow works with Gatling, it's going to prepare the load gen, deploy it, run it. In parallel, I'm going to do a CPU hog. So I'm going to consume all the CPU of the system. So it's going to get high user transactions as well as high CPU utilization. And then the test will safely stop the load gen after the chaos experiment runs. And then I can kind of get a repeated result. So if I just run this and then select the input set. So this is like the pre-programmed configuration I'm sending. I can apply it. And here I have my definitions that Gatling's expecting. And then I can just hit run pipeline. So now this test, I just hit run. But you can also schedule this test, pre-program and run it. And all the configuration, it might look a little bit complicated. Initially, when you start something, right, you always have like this much configuration or YAML to put in. But once you have it, it's once and done. And as you know, with like load testing, it's getting that first configuration for load testing working, and then it usually just works just fine. So now I'm orchestrating my load testing through Harness, and then I'm running a chaos experiment with that. And the app that this is running on is just the online boutique that Google provides, where you can, add stuff to your cart and check out. And then I have this tied in with my Grafana dashboard as well. So here I can see my load testing kicking off and different measurements responding. So I can see, again, is my application performant? And then how does it handle load tests as well as, a CPU exhaustion experience as well. So if I click on the chaos experiment, you'll start seeing like this score. And if I go into the detailed execution of this as well, I can just start seeing this running. So this is actually the chaos experiment workflow that's tied in to that pipeline experience that I showed you. And this is all just within our chaos engineering product. But I actually have a step where I can evaluate the rules. So this is back to like the guardrails, security and governance that I talked about. So I can actually program it to just say like, hey, we're going to have a period where people can't run any tests on Friday, Saturday, and Sunday. And That's where this evaluate rules happens. So if you have a developer that maybe doesn't know that, we can actually like block that, kind of like a firewall rule with that. But here I can see that my chaos experiment was running. I actually configured a bunch of monitoring probes within this. So one thing great within the chaos experiment, I can have like an HTTP check that kind of runs continuously. And this is just polling my URL to make sure that it's, a 200 HTTP response so that it's healthy and responsive. And then I have various other probes. It's kind of like a pre-flight checklist during the experiment, as well as like during the flight and then post-flight of the experiment. I can have these all checked. But what I'll see is one of the latency checks failed. So I was expecting it to be like less than 50 milliseconds, but it was over that. So then that probe failed. So then I can see like I had an 80% resilience score within this test, which in this case, I configured it to pass. So every probe can be weighted so that you can configure the test very specifically. And then if I go back to that pipeline, I can see I have my whole test here. So it, successfully did the load generation with Gatling to do more of that load testing. And then it coupled it with the resource exhaustion through the CPU. And then if I click on like the resilience tab, it pulls in all of my information for the probes that I had. Because again, it's not just about like injecting failure into the system, it's about measuring it so you can repeat it. But then you can have this report of the tests that you can consistently run. So you could imagine, as a DevOps or QA engineer, right? We had a new bit of code, and now we just deployed this application and ran this test with load testing, right? I'm not going into the load testing tool and all these other tools. I'm running that orchestration through one tool. I can do it through the UI or API, no worries there at all. But then I can do that for every deployment. And you can do this in, QA or dev or lower environments as well. You don't have to do it in production, but you can for sure. And if I go back, like I have some other tests that I could run for Load Runner or Locus or JMeter, BlazeMeter, what have you. But in this case, I just did the Gatling for that. And then some other parts of the demo that I'm going to do. I'm just going to do a quick check to see if anybody asks some questions. Yeah, and I'm just going to answer this question quick just because people, so Richard asked, can you link to a monitoring URL like Datadog to see if the test is impacting a particular service? I just put that in the publish. Okay, but yeah, just to re-clarify, with a probe, and I can actually show you here too. So within a probe, whether it's for Kubernetes, Linux, or Windows, what have you, we have an integration with Datadog, Dynatrace, Prometheus, or Kubernetes, so you can interrogate the local Kubernetes system, like how many pods are up, how many containers, etc. Are there system events? And if you see, like you don't see New Relic on here yet, we could easily add that, but our workaround for that is using our other like command probes so we can query and interrogate those systems as well. So if you have like a local monitoring system and observability system that you use, we can tie into that as well. So yeah, great question there. So as part of my other demo, I'm going to just talk through some new AI capabilities and features. What we found with chaos engineering is, initially it can be hard, to use and adopt. A lot of people do, a snapshot reliability test where they're doing, the once a month, they're doing those game days or pizza parties, right, to test. But how do you make it easier so that somebody can, log in every day or log in every deployment or just have something automate and kick? And that's where we are leaning into Gen AI and, doing all that fancy stuff as well. And we've actually created this Kubernetes Watcher agent that's kind of deployed with our chaos engineering infrastructure. And it's kind of looking for system changes that are happening to the configuration of Kubernetes, right? And one part of the demo that I'll kind of showcase here So I'm going into my Google console, and I'm going to scale this down to 1 replica instead of 2. And this Kubernetes watcher agent will kind of see that, right? And as I do this, I'll actually see like that I get some, oh, there we go already, some experiments I should run because of that system change, as well as if I go to resilience probes, I'll get some AI recommendations for things I need to fix. So no longer is it about, like running a test and seeing what happens. We're actually seeing what's changing in your environment, recommending what tests, recommending what fixes. So as you get started with chaos engineering, maybe it's not about running your first test. It's maybe about seeing like what's already wrong with it, right? So you can proactively fix what's already there that you already should know about. And while this runs for a few more minutes, I was just going to kind of show another chaos test that's kind of fun to run. But basically, I have this pod DNS spoof experiment. So anytime there's an incident, it seems to always be some sort of DNS issue, so it seems. And in this case, what this is going to do, it's going to be more of like a security experiment where I'm spoofing the resolve configuration of this, right? So if I actually run this, I'm going to just run this DNS spoof on this pod. So it should be pretty quick, and then we can get back to the other part of the demo that was finishing up with the replica change. So I'm going to click into this. So now we can see like this test is running. It's currently queued. So it's evaluating the rules. Matt can run this test during the webinar, no problems there. And now it's going to actually run this DNS spoof. What's great about this experiment is you can see all the logs that are happening. So you don't have to go like query your pod to understand what's helping or hurting something. And then if I go to this demo app, what this is actually doing, so if you see the pirate or the hat that's on here right now, we're spoofing the DNS so that now Mr. Potato has, the different hat on it and stuff. So this is like a fun experiment to test DNS to see if you can spoof. So like a security engineer might really appreciate this. Now, granted, everybody probably can protect against this, with access controls or like TLS type stuff where nobody's going to be able to spoof it. But this is kind of like just a fun example of what you can do with chaos testing, as part of this resiliency example. All right, so now I'm going to go back to my chaos experiments. And cool, I got a few things I can do here. So I'm going to create this container kill experiment and run this. So again, this is all pre-configured, auto-recommended, so that I can run that as well. It's also telling me, hey, the deployment only has 1 replica because I just changed that, which is less than the recommended 2. So now let's test the resiliency of this. Now I know if I run this, it's going to like break the app because I'm going to kill the only replica that's there. But since I'm in a lower environment, I'm going to run it anyways and kind of show it. So these are all queued as well. I'll go back, and then it also recommended some other experiments. So the Archaeate's watcher agent. So I'm going to hit run on this. And again, what's cool, we leverage another open source tool called KHGPT. So that's another CNCF, Cloud Native Compute Foundation project. But we actually use that to understand the context of this. So here it's saying application is experiencing intermittent network latency. So it recommends running this test proactively as well. So I'll run that. And as you can see, if I was an engineer, I'm learning like what's new out there that I need to run, as well as kind of seeing what I need to fix. So now maybe in general, I wouldn't run 4 chaos tests at one time, right? Like that might not be the best, but you can. There shouldn't be any conflicts with what I ran. You could also create 1 test with all 4 of these experiments running in parallel or sequentially as well. So like with our orchestration layer, we can run, increase the CPU and memory and add some latency all at the same time. Because as like big incidents, it's never just like one issue, it's multiple issues and everything like that. So some of these tests are going to pass, some are going to fail, but at the end of the day, like what ends up happening. So after I run these experiments and I get a resilience score that I can measure my posture, I actually see some things that I can go and fix. Now today, I'm not actually, like, harness isn't fixing, but if I go to this right here, I can see like, hey, there's this failure reason. Here's why. And if I click on fix, I can learn about that issue that just happened, right? That just got exposed. I can hit ignore, I can acknowledge it, or I can create a JIRA ticket. And honestly, as a product manager, sometimes my favorite features are just like being able to integrate with JIRA, because then it can create JIRA tickets automatically. In this case, it's very detailed. So I can create that JIRA ticket to go on my backlog as an example. And then as with working with my team, I can prioritize that fix as well. So, and here's another one, right, that's just talking about another issue. So in this case, maybe I'll just hit ignore as just an example. But these are all like great ways to work with chaos engineering, right? So like when you start using it, you can kind of just see what are the recommended tests based on your configuration, see what you should maybe fix before you run a test, and then run more tests programmatically. Awesome. I'm just checking out our chat and QA here as we near 51 minutes. So I've got a few questions. All right, so I'm gonna answer that one. That one's good. So I'm gonna go back. Couple new questions. Just gonna publish a couple. All right, so in the publish, so what I'll just read the question too. So who should own chaos engineering, QA, or DevOps? So this is good. Actually, let me switch back to my screen as well. So the use cases that I was talking about earlier. So for example, this Istio resilience. Now this was like the platform team that wanted to do this test. But to answer your question, what I see based upon working with customers and talking with prospects is a lot of performance and QA engineering teams are starting to own this. They're realizing how simple it is and how it makes sense to do load testing coupled with chaos engineering. And then like the DevOps team, I also see using chaos engineering, right? So various teams depending on where you work, but definitely performance QA engineering teams are starting to own this as part of their pipeline. You know, they're creating that, I wouldn't want to say a governance gate, but you know, a governance gate to kind of, before it goes to production, you know, I'm going to run these tests, right? Maybe like a site reliability engineer who's protecting production from incidents is leveraging the QA team to kind of bless off that new application code. And then organizations that just have like the DevOps teams, like they're definitely owning it, or like a platform team is enabling it for self-service. So that goes for that question. And then we got that in the answer. And then another question, let's see. I answered Richard's already. And then one more, can you do a pod deletion test to validate that Kubernetes has regenerated the pod successfully? Yes. And actually this use case that I have on my screen was basically that as well. So it was doing like a pod delete experiment and then using our probes that I was showing you before, whether I was connecting with Datadog or in this case, it's running a script to query the Kubernetes system. You can actually see like how quickly that happened, right? So you can understand and measure the startup times to see if you need to tune your readiness probes or liveness probes and all that. Cool. Let's see, we got a few more questions. One more. Is it possible to use agentic AI to just fix the issues that are found instead of just creating a Jira ticket? Yeah, so it's a great roadmap question. That's the goal for sure. You know, we still want to keep humans in the loop with things so that they make decisions. But eventually, like what you'll see on that screen is, you know, acknowledge, create a Jira ticket, or fix. Like if it's a known issue, maybe, and hopefully known issues don't happen anymore. But yes, how can I go, whether that's like in my IDE and change some code, or is it something in my infrastructure as code management that I can redeploy because maybe I need to resize my infrastructure? Definitely want to make that easier for developers and the like to fix things automatically. And what's brilliant about that is, I think that's definitely going to happen with agentic AI and all the model context protocols that are happening with various tools out there for sure. Great. And then that was the last question, which was a very good question. So thank you for asking that. Let's have a few more slides to kind of wrap it up. So coming up this week, if you're in San Francisco, Friday, April 11th, we're helping host SRE Day for a third time. SRE Day is a great conference out there for the past few years. The same people that run Conference 42 run SRE Day. So go to SRE Day and sign up for that if you're in San Francisco. They also have various spots, in London or Washington and all that kind of stuff. If you happen to be in San Francisco, throw something in chat and I can hook you up with a coupon code to attend as well, because I'll be there. In January, we had our big Chaos Carnival virtual event. It was our 5th year, where we had tons of people talking about incident response, incident management, and chaos engineering. So you can go to Chaos Carnival's website to see those on-demand videos. You just have to enter your email address. They're all free. Every year we have like a Litmus Chaos conference as well that we partner with the CNCF, the Cloud Native Compute Foundation. So that's on there as well. It was this past September, and that's not scheduled quite yet, but it'll be there. And then we also, at Harness, we have certifications. So if you're looking to get certified in chaos engineering, we have a couple of levels that you can take. And what's great about that is we actually give you a Kubernetes sandbox environment. So I would love for you to install chaos engineering on your own infrastructure. But if you need to work with a security team and don't want to wait for that, you can still pass this certification by using our sandbox environment. We give you a Kubernetes namespace for 2 hours where we actually walk you through running chaos experiments and fixing it too, which has been great. And then let's see, I'll leave this up here as well. But if you want to go to our website to book a demo or create a Harness free chaos engineering account that's free forever, the only thing we gate is the number of experiments per month. Otherwise, you can run it to your heart's desire. Click that or scan that QR code with your phone. Also, if you want to connect with me on LinkedIn, happy to network, learn from you as well. Or if you want to book a meeting on my Google Calendar, nobody's done that yet. So I challenge one person to book a meeting with me. We can talk about load testing or chaos engineering, learn from each other as well. So feel free to do those as well. And I already kind of walked through the Q&A, but just for fun, in chat before we sign off, I'm just curious, what's your favorite tool to wreak havoc these days, so feel free to put in chat what that tool might be as we end out. But that's all I got today. I appreciate everybody that attended. Great questions, and thank you so much. And Jared, turn it back to you.
Yeah. Hey, Matt, I want to thank you very much for today's program and remind everyone that before we close out, we do have all those resources or handouts in the resource section. We've also got a quick survey in there. It's 4 questions. Your input is invaluable to us. It helps It helps us here at TechStrong know what programs you want to hear about or what content you want in the future. It also helps Harness know what they can do to improve, what you liked, what you didn't like. It helps them, with the same information. So once again, this program was recorded. You will receive an email in your inbox shortly after we conclude with a link to view it. You can share it with your friends as well. Get people to watch it, view it, make more comments on the content. Once again, Matt, I want to thank you for taking the time to join us. It's been a pleasure having you, and we hope to see you all next time on our TechStrong Learning programs. Thank you, everyone.
Yeah. Thanks, everybody.